Hi, this is Aditi, and December I worked with the contractor database. So on the front end, I built the Find Remodelers page using Next.js, which has search and based on zip code and normal search, and then there are certain filters that we added to this page. For storage purposes of this, we use Supabase, which gave us like the Postgres database that we use to store all of this information. To see it and enrich these contractor details, I also wrote like a Python script that like queries through and scrapes through the Google Maps API to populate these results and load them into like Supabase. And it also has a duplication check. Through this, I learned a lot about databases, database indexing, and query optimization, as well as like API integration between Next.js and Supabase. On the data side, the data pipelining side, I picked up practical ETL techniques like handling rate limits, pagination, and messy real world data. So, the key challenge that I faced was basically getting and scraping this data and then making sure it aligns with the schema that we had. We had three tables, and we may had to make sure that the querying is efficient based on the real time data that we get. Also, the fact that we had credit limits. So this is how the database was. We had three tables and we had credit limits, and I had to make sure that every time it hits that credit limit, I need to change the API key. Um, so in the future, we wanted to add more filters here, but then for now we have these filters. And if you do like a search, it basically like removes all of it for you. So like American Home and remodel. So if you write remodel here, it filters based on that. And if you like write zip code here, it also does that. Of course, there's no, yeah, this is what we get. Thank you.
Hi everyone, this is Dan Lin. During this summer, I've been working on develop this minimum viable iOS app that uses LiDAR and camera to scan rooms and convert them into 2D floor plans for calculating square footage in remodeling projects. There are 6 main features in this app. The features are LiDAR room scanning, real-time 3D capture, 2D floor plan generation, square footage calculation, export options, and remodeling estimates. Something that I learned during this building process is a deeper understanding of the market of home remodeling and apply the model view model architecture to develop this product. My initial task was to develop this room scanning feature on our website on homeviz.com, but later we found out that the LiDAR feature cannot be used by the website. It can only be used by an iOS app, and that's how I started building this app. The second challenge that I faced was running out of the storage on my computer. I didn't have enough storage to install the simulator on Xcode during my building process, and my founder helped me solve that problem by bringing me a USB drive to clear some space on my computer. Then I was able to run and test the app on my computer. Now I'm gonna show you a quick demo of my app. Initially, it lets the user to start scanning by directing the user how to scan the room from top to bottom, and then it generates a 3D model on the center of the screen as the user scans through the room. Then after user finishes scanning the room, it will generate a results page that has the summary of the room, such as the number of walls, windows, and doors. After click on export as PDF, it exports the report for this room scanning. There's also a 2D floor plan on this report. As the next step, the accuracy of this 2D floor plan still needs improvement since I didn't test on the whole room, but it inferenced the whole room based on what I scanned, which wasn't quite accurate. And that's all. Thank you for watching.